Is problem 1.28. It says a 50:1 worm gear reducer is bolted down at A and B, and input torque M1 of 15 Newton meter turns the worm at a steady rate in the direction shown. The output shaft rotates as shown against a resisting torque MO. Neglecting friction in the gears, estimate the force acting on the housing at A and B. So this torque right here is your output torque, and this one right here is M1. And the coordinate system here is that this one is x, this is y, so this right here is going to be your z-axis. So the input torque M1, if you notice, this is acting in the negative j cap direction, and similarly your M output is acting in the negative k cap direction. Now for the housing forces, let's say these are the 2 points, so we can mark 3 forces here and 3 forces there. Okay, now we can call them FBX, FBY and FBZ. Similarly here FAX, FAY and FAZ. To find out these forces and moment, we can do the force balance. So force balance will give us FAX plus FBX equals to 0 in the x direction. Similarly in the y direction, FAY plus FBY equals to 0, and same thing in the z direction, FAZ plus FBZ equals to 0. Now there are total 6 unknowns here, only 3 equations, so let's look at the moment balance also. And since we are looking for these forces, first we'll take the moment about point A. That way all the forces at B will appear in the equation. If I am taking moment about point A, these are the only forces that will give you moment there, and if you use the idea of R cross F, so the forces are at this point, so your R vector is going to be A to B, so that I can write it as 270 mm I cap, and your forces here are going to be FBX I cap plus FBY J cap plus FBZ K cap. So if I do this dot product here, it will be 270. I cross I will give you 0, I cross J will give you K cap, and I cross K here will give you minus J cap. So in addition to this, we have these 2 moments, which are your M1 acting in the minus J cap direction and your MO acting in the minus K cap direction. So the overall moment is going to be this total here, and which needs to be equals to 0. So now you can see, if I compare your J cap term here and if I compare your K cap term here, from this I can get the value of FBZ to be minus M1 divided by 270. Similarly, the value of FBY from your K cap comparison can be written as MO divided by 270. And remember, this is Newton meters and this one is millimeters, so that's why there will be a difference of 1000 there. Now one important thing that we have not discussed so far is this gear ratio. Okay, so if the gear ratio is given to be 50:1, now this is the ratio of output torque to input torque. Now input torque is given as 15 Newton meters, so that's why your output torque is going to be 750 Newton meter. So now we have both of these values, M1 and M0. So if you substitute this, your FBZ value comes out as minus 55.5 newtons, and FBY comes out to be 2778 newtons. Once we have these two, we can go back to our force equations here. We have the value of FBZ and FBY with us. So from this we can calculate the value of FAZ, which is going to be negative of this, so 55.5 newtons, and FAY is minus 2778 newtons. So in terms of forces coming from the support at the ground, there were total 6 forces, and we have figured out this, and this. And these two forces here, there is no information coming from force and moment equation, except for that they'll be opposite of each other. So in terms of value, these are indeterminate forces, FAX and FBX. So as an approximation, we can take them to be equals to 0. So these are the known values of forces that we have got, and these two forces are 0.